for the last part, you're told that if n goes to infinity, write down the relationship Rzn and imaginary Izn as n goes to infinity. Write down the linear relationship. Okay, deduce first. So we're going to deduce the first one first. Here. Okay. So as n goes to infinity, we look at argument Zn. So and this is part 3, right? Okay, part 3. So as n goes to infinity, let's look at what happens to argument Zn. You realize that this one here and this one here. Now there are a few ways of doing this. You could write that argument of 1 plus ni will be the same as argument of 1 plus n plus 1i. Okay, the reason being is because n will just become n plus 4. Like roughly at infinity, they if you have $1 billion and $1 billion and $1 is $1 billion and $1, it is roughly the same. So you could just write this as they are the same. So to let's say this is equals to let this the same, right? Let it be a value. I'm not sure what value you want to be. Let's say, okay, let this be theta. So in other words, this will be theta, this will be theta as well. So argument Zn, this is method 1. Let me just method 1 here. So this will be minus 1 over 4 pi minus theta plus theta, which is actually Zn equals to negative 1 over 4 pi. Okay, so this is method 1. Method 2 would be also the same, actually the same idea. If n goes to infinity, okay, argument 1 plus ni will just go to pi over 2. Argument 1 plus n plus I also goes to pi over 2, because they tend to infinity in such a way that you have 1 out of 1, it will just be a vertical line. Okay, so it doesn't matter, like your 1 is so small here and this is like infinity, you draw the line, it will just be pi over 2 . So that's the idea there. So anyway, this is the same. This theta will be pi over 2 as well. So you just say, okay, so actually it's the same concept, just approach it slightly different. Argument Zn will become minus 1 over 4 pi minus pi over 2 plus pi over 2, which is actually just minus 1 over 4 pi. Okay, that is your first part. Okay, that's it. Now you're asked to then show, hence write down a linear relationship between the real part of Zn and the imaginary part of Zn. Where's the real part of Zn? Real part of Zn and imaginary part of Zn. Oh, so if it's pretty okay, right? If any argument Zn, if it's negative pi, so this is what is going on. You're looking at this line here. This is negative 45 degrees. Negative 45 degrees. Okay, so this over here will be the real of Zn, and this is the imaginary of Zn. Means it registers the Zn, real or imaginary. This line here just give a value. For example, if this is 45 degrees, means this is like isosceles triangle, right? So you are looking at, if this is, say this is 2, this will be minus 2, right? Because it's 45 degrees, it's actually y equals to minus x line, right? So look at the argument. Remember, the argument tells you how the complex number behaves. Okay, whether it's like purely imaginary or real number, the argument tells you how it behaves. So in other words, you could just write down, hence real of Zn is actually, you will just take a negative. So if this is 2, this is minus 2. If this is 3, this is minus 3, right? So you would expect this to be, it will always hold true. So you would expect this to be a negative real Zn. That's how it behaves. Okay, so imaginary Zn. Let me rewrite it properly. That's about it. I think that's pretty okay. That's how you do this question here. If you have any questions or comment, please let me know. See you in the next video. Keep practicing.